And what was the problem with the design of the Chernobyl reactor? Yeah, they didn't have a containment vessel.
But life is going back. I can see pictures.
Now in Japan last year, what happened in Japan? Was any radiation released?
Yes.
Yeah. And it turned out that what happened there, if you go back to this picture.
Did the tsunami break the containment?
It didn't break the containment, so what happened was that the tsunami, it flooded the pumps, and then water couldn't be pumped into the reactor to cool down the fuel rods. And then some valves got stuck. They couldn't close some valves. And some hydrogen gas was released. It blew up. There were some hydrogen gas explosions within the reactor core, and some of these valves got stuck open. They couldn't close them in time, and there was some radiation was produced in that accident. So you're going to find out as engineers that when you design a process or design a plant, you often do not design it under the very, very worst case scenario, because that's going to be very, very expensive. Okay, so you're going to design it to within, say 90 or 80% of the worst case scenario, because what's the odds or what's the chances of the worst case scenario ever happening? And it turned out that in Japan last year, the worst case scenario did happen. Okay, so that's what, and then we as the public, that's what you don't like to hear. So anyway, you'll learn all this stuff when you learn about your engineering design things and things like that. Okay, so climate change is occurring. There are a group of non-believers who don't think that climate change is true. Now, I'm not quite sure if the warming of the Earth is due to CO2, but I do believe that the climate is changing. Okay, but let's actually let's compare which fuel is cleaner: coal, natural gas, nuclear, hydroelectric, solar, or wind. So what do you think is the cleanest type of fuel to use? Solar? Wind? Nuclear? What's hydroelectric anyway?
That's just water.
Yeah, water and yeah, but see, one problem with hydroelectric, you need water. Yeah, you need water for that, and then you also have to dam up these rivers. And sometimes people are displaced. In China, they had to displace quite a few people. I guess a million. They flooded more than several towns, and quite a few people were displaced, so they could build this big dam in China. Let's take a look at this table. This I know it's small, but let's compare these energy sources. So, for example, coal. 50% of the energy in this country is produced from coal. Yeah. There are 600 coal-burning power plants in this country. The cost is 1.82 cents per kilowatt hour. Now, the base load, that is, you can always get electricity as long as the coal is burning. For CO2 emissions, this produces 2 billion tons of CO2, or 36% of the total CO2 produced in this country. Now, there are other substances emitted as well. Sulfur dioxide, which produces acid rain. NOx, this is either NO or NO2. Okay, so this substance is also produced in the tailpipe of our cars. Note also, coal contains mercury, so mercury is also being spewed into our atmosphere too by the burning of coal. In terms of particle radiation, it's negligible, although there's a little bit from uranium and thorium. So in other words, there's some uranium and thorium found in coal. And for waste, there's 1,000 tons of coal ash produced per day. The coal ash will contain heavy metals such as arsenic, barium, beryllium, boron, cadmium, chromium, thallium, selenium, all these things here. The waste kills 24,000 Americans per year. Natural gas is used to produce 25% of electricity in this country. I'm not quite sure how many natural gas burning facilities there are in this country. It costs 5.2 to 15.9 cents per kilowatt hour. So note that natural gas is more expensive to burn than coal. although the price of natural gas has gone down significantly in the last year or two. There's actually a glut of natural gas in this country. Once these natural gas burning power plants are burning, that produces a constant base load of electricity. For nuclear power, there's 20%, that produces about 20% of electricity in this country. There's 104 nuclear power plants in this country. The cost is actually cheaper than that of burning coal, 1.4 to 1.9 cents per kilowatt hour. Again, it's a constant base load. CO2 emissions is very low. About the same as wind power. Radiation is very negligible, 100 times lower than coal. The waste of radioactive isotopes with short half-lives, the rest is recycled. And at least according to the California Energy Commission, no deaths to the public in 50 years of operation. Hydroelectric dams produce about 5% of electricity in this country. The cost is even cheaper, 0.25 cents to 2.7 cents per kilowatt hour. Again, as long as the dams run, that can produce constant electricity. Again, very low CO2 emissions. Now for solar and wind, that produces, this is actually a higher percent now, 1 to 2% of the electricity in this country. So when our current president was elected in 2008, he promised to double the amount of solar and wind power produced in this country. So that's not much. Going from 1% to 2% isn't really a big deal.
Still double.
The cost of solar energy varies quite a bit. It's expensive. 13.5 to 42.7 cents per kilowatt hour. For wind power, about 4.6 cents per kilowatt hour. The problem with solar and wind is that you only get electricity when the sun is shining and when the wind is blowing. Because we still haven't figured out a way to store that energy, for example, in a battery, where you can then tap the energy from that battery. And CO2 emissions are very low. Love it. Okay, so here's another one on coal. Coal is the main source of electricity in the world. So in 2007, let's see, there was 1,425 gigawatts of electricity was produced from coal-fired power plants, and that's out of 4428 in 2007. So that's about, let's see, 1425 divided by 4420. What is that, about 35% or so? Somewhere in there. So note that although coal is dirty, there's no such thing as clean coal. Note that the prediction is that in 2035, we're going to almost double the amount of coal which is being burned. Okay, so one thing that you'll also learn about as you earn your money is how to use your money to make it work for you. How to invest your money. So whether you buy stocks or bonds or and that kind of thing. So maybe investing in energy, I won't tell you what type to invest in, might be a good idea. Especially based on these numbers from the DOE. And in this book here, The Power to Save the World, was written in 2007 by this person who was an environmentalist who thought that nuclear power was just the scourge of the world. And then this person looked into nuclear power and wrote a book on it and said that maybe nuclear power isn't such a bad thing after all. And then here's some more stuff on nuclear power. And here's some more things on the next generation nuclear power. They're on generation 4 now. And these latest generation power plants work on the same principles, but they operate at higher temperatures, they're different in terms of coolant, fuel assemblies, neutron energies. Supposedly they're safer too. And then here's a picture of a sodium-cooled fast reactor. So rather than using water as the coolant, they're actually using sodium. Okay, so the heat, so in other words, the nuclear fuel is heating up the sodium, and then the heat transfer from the sodium is heating up water, and then it's producing steam, and that's powering the generator again, just like the coolant. Okay, so note that the coolant is different in this type of power plant than others. And this allows higher temperatures to be used. Okay, then nuclear fusion. We talked about fission. Fusion is the other type of nuclear reaction, because that's the type of reaction produced in the sun. So this is when you have small nuclei colliding together to produce larger nuclei. About 20 years ago, nuclear fusion was thought to occur on the lab bench, but no one could get that reaction to happen, to be reproduced. So people are still working on cold fusion, although we're still not quite sure if it actually works or not. Then there's also radioactive isotope used in nuclear medicine for diagnosis and therapies. One type is boron neutron capture therapy. So this is actually used in various types of cancer therapies. Now you can take a look at this one if you wish. There's also a section in the textbook on nuclear medicine, and then so we won't take a quiz since we're done with the quizzes this semester. Okay, so then next Tuesday in class, I'll spend a few minutes talking about coordination chemistry, and then we'll review for your final exam. Okay, so in lab today, we'll spend that time trying to catch up with labs you need to do.